Our next speaker, Gertjan Verbaan, he will be presenting the future daylighting standard. He has been working at the building physics company DGMR for over 30 years. But next to this, he has been also for 18 years already part or member of the Dutch Daylighting Committee, Standardization Committee. Within this committee, he has been contributing to the European standard, so the 17037 that you've seen before in previous presentations, but also the Dutch practical guideline, the NPR 4057. Since 3 years, he is currently chairing the Dutch Daylighting Committee, and quite recently he also joined the European Daylighting Committee, the working group 11 on daylighting. So let's hear more about this Future Daylight Award. Let's welcome Gertjan.
Thank you. Can you all hear me? Okay. Yes, I would like to tell you something about daylight, of course, because that's why we're here. This is sort of the content of my presentation. Might be a bit more technical than we've seen in the presentations before. So if I see people sort of sleeping and so on, I will sort of speed up my story a little bit. I would like to start with this one. Might be familiar because it has been awarded with the Dutch Daylight a few years ago, and it's something I really like. It's a museum Voorlinde in Wassenaar, and what's actually nice is also the museum and the exhibitions that are there, but also the roof, because the roof is really designed for daylight. There's no sun getting in, but there's a lot of daylight coming in through the roof. This is not a project. This is a project we did as DGMR with a renovation of an office in Utrecht, where they actually changed the facade completely, but also changed the angle and the orientation of the facade. These are a little bit of those pictures. So we can see that also in projects we do, and this is another project we've done ourselves, that daylight is really important. This is a hotel in Amsterdam. So as a consultant, we're very much into projects working together with architects, and we're more on the technical part, you could say, where we sort of contribute to solutions, and we also use our own software for this. Because during the more than 40 years we are there, we have also built our own software, and together with this software we're able to make different solutions. So that's what we're doing ourselves. But first of all, it's springtime. So that's the time when daylight is really important. You can see it in nature, and this is a picture I took, I think 2 weeks ago in our backyard from a pear tree which is sort of blossoming because of the light which is there. And it's also very important for us as well, of course. And we see that the light is changing during the year, and now we're getting the longer days, and we're feeling much more happy. And a lot of people were standing outside in the sun because they were sort of enjoying those early days of the year. And we really need daylight, and we need sun. But it's not all the same in the Netherlands. Most of the time we look at the center of the Netherlands, but as we can see, there is a difference. So in the middle, if we take the build, it's sort of 1025 a year. And if we take, for example, Hoek van Holland, it's over 1100. If you go more to the east, you can see it will be less. You wouldn't think so in a small country like the Netherlands, but it's up to 10% difference in the total amount of light each day. And we do know that daylight is really important. It has been before with some of the speakers. So the color is very important, of course. The brightness. It also setting the atmosphere. It really does something with a room. But it also helps you in terms of physical health with vitamin D, emotional health, you feel happy or maybe depressed on the other end. And it's age dependent, and we see from research, and only a little bit about it, but you can see that it really helps people when there's enough light. Francesco told about the winter depression in Norway. Well, especially something you can see also in the Netherlands with some of the people because of less light. So that's the importance. Daylight gives energy and gives you energy. In the past, we thought that there was a tendency to smaller windows due to energy requirements. We can see in the Netherlands that we have the energy requirements for bang, and people tend to make their windows smaller because of the bang regulation. I don't think that's necessary, because if you really look at energy and you look at a proper way to where you put your windows and what you do with your windows, daylight also gives energy. It reduces the amount of artificial daylight, and today, if you have a good skin of your building and if you have an efficient generation for heating and cooling, those are not the things which you should take care of. It's more about the fans, the lighting and the hot water, which you have to address if you want to have a good energy performance. But we also see that daylight gives us a variation in color temperature. You can see the sunrise in the afternoon and the sunset. That's something that's really different from artificial light. But there are also some daylight problems which we have to take care of. And there are different things. I'm not going to go down everything, but you can see that there are some things where there is too much light. And then, for example, there's no brightness barrier, or there's no control over the barrier, or there is reflection of sunlight because of buildings on the other side of the street. That's something you have to take into consideration as well. And that's also something which is in the standard. I'll come back to this. I also researched some of the history, and from the early days, even before my days at the committee, I found these documents. They are in Dutch, and there were just pictures of what was written down, but it says something about history and how in the Netherlands we had our regulations, well, this up to almost 70 years ago. Then there was something in our building degree, you could say, which was based on a sky factor. So you could say that we looked at part of the sky factor, which we saw. This is sort of the sky you can see. And what was the part of the sky you could actually see inside of a room? This is something which is sort of similar to the daylight factor, which is in the new standards. So 70 years ago, we already had this in our documents. This changed a little bit during the years, and then we got something where we only looked at the window, and then we looked at obstructions outside of the window. And this was also something written, it's in Dutch, but it says something about what was there previously, and there was the sky factor for 1%, was sort of the daylight factor, but also in other countries, they had a minimum daylight factor, instead of the 2057 we're having. And it was based on a lot of research in the 80s, and eventually it was written down in the early 90s. Then they made a comparison between all those different methods, not going too much into detail, but you can see that all was related to the vertical illuminance on a window. So everything was based on how much light was coming onto your window. Not onto your room, but only looking at the window. So that's a little bit about the history. So we go back from the archives to the current situation. These are the requirements we're having in the Dutch building degree. And it says something about the equivalent daylight area, a window to floor percentage. It's different for each category. So you have residential and you have office, for example, but it's really different. And this is more into detail, and then we have, for example, the 10%, but we also have a minimum of 0.5 square meters for the room. and we have the equivalent daylight area. We do not take into account obstacles from a plot outside. So if you have an adjacent building, you don't take it into account. That's something which is written down in the Dutch building degree. And daylight openings that are less than 2 meters away from the plot boundary are not taken into account. So if you have a window really close to your boundary, you cannot take it into account because your neighbor might be building something over there. And as a sort of a minimum angle you should take into account. Well, don't mind that. Then I have a few questions for you. You can see 2 windows over here, and I want to do a little test and see how you know the Dutch standard, maybe what you should know about this. We have a window A, which is more of a vertical window, and we have a window B, a horizontal window. Both similar in the surface, and I would like to see people raise hands if they think window A is the best. Well, not that much. So everybody, the rest says window B is the best? Well, there is something wrong with this picture, you could say, because actually we don't take the bottom into account. So the first 60 centimeters we're not taking into account. So this was a little bit of a trick question, so they're not equal. But let's say we do it again. We have 2 windows. We have window A and we have window B. In this case, it should be window B is better. No, it's not. Window B is worse because you can see because there's a reduction factor for 34% instead of the 74% you can see with window A. It has to do with the thickness of the wall because you look at the surface on the inside. So that's what you take into account. So if you look at these 2, window A is the best one. Then there's another one, also from the current standard. We have 2 windows, window A and window B. Which window provides better daylight? I'm not going to ask you to raise hands, but actually window B does something like this, and window A does something like this. But if they're the same windows, the same size of windows, and the same shape of windows, they would be the same according to the current standards. And that something doesn't feel right if you look at how light is coming into this room. So it's a little bit of realization how the current standard works. And actually, if you look a little bit further, and if you do a light simulation with radiance, for example, and you have different windows, you can see that you have a whole different pattern inside your room. If you look at what's going on inside your room, it will be totally different. And according to the standard, they would be the same in this case. There is something extra which might be nice, and I don't know if everybody knows, but there's also an extended method. That's a little bit of extra which is in the current standard. And it can really help you, and this is from a building researched ourselves. What we did is we made the calculations and we showed how much light or what the objection factor was on each window. And if you put this in a different color, you can easily see where the problems are. So this really helps a lot better than if you just have something like an Excel or whatever and just numbers. This really shows something. This is according to the extended method from the current standard. This is something I found on my way to the office. I was driving by on my bike and I saw this and I thought, well, this should be a nice case to say something about. First, we can see a lot of balconies. It's an apartment building. It's in The Hague. And we did some math on this. So we made the different calculations. And again, we have an A and a B window, and the B window is with the balcony. And something interesting is going on if you look at the current standard. And this is the simplified method, which is in the standard. And then you just look at what is above the window, and you say only in one direction you can say what is happening. And then you will have a difference where you can see that window A is much better because it has 77%, and window B will be something like 52%. This is according to the simplified method. There's also a more extended method where you can look in different sections. So instead of just looking at one angle, you can look what is going on, and then you can also take into account the balconies from the other windows. Because if you just look what's above you, there's no balcony for this window. But on the left side, from the right side, there are balconies. So they will have effect. And if you look at the standard in this way, then you will have numbers like this. It would be more equal. Because in the end, there is some obstruction. And is this really what's going on? Is this really the truth? If you look a little bit further, we did it again, but then we use the extended method. As I said before, where you make calculations and you look at how much light is coming onto this window, but not by sections or just with one angle, but looking in all different ways. You're looking at the total sky dome, what's happening. And then you can see that there is less difference, and that even the one underneath the balcony is worse. And it's also because of the middle one, the A window. It gets is obstructed a little bit by the balconies on the left side and the right side, but there's also reflection. So you can see different ways. It doesn't have to do much about the numbers, but different ways of calculating in one standard that will lead to different conclusions. And for a reality check, we also looked at the European method, let's say the future requirement, and then you calculate what's going on inside the room. And then you see all different patterns, but you see these patterns, and then you can see that window A does a lot more also on the very first few meters of the room, but also in total is better than what window B is doing. And this is much more in detail. That isn't. Look at an overview, then you can see that you have all these different methods. According to the simplified method, there's 3.61 square meters. The method with the different sections says there will be a total of 3.72. The extended method varies a little bit, but you can see that it's between 3.5 and 3.64. And if you would look at future requirements, you would have a target daylight factor of 0.9 for window B and 1.9% for window A. Interesting thing is this is the same building as you saw before. But I got along, I had to go to the office, and on the other side of the building, this was going on. But according to Dutch standard, the red building isn't there. So in terms of daylight, you wouldn't have to take it into account, but it will be there. So reality is a little bit different than standard is. Then on to the new standard, the 17037. It's the European daylight factor, which we would like to have in the Netherlands as well. One of the main things in there is the minimum daylight factor, or the target daylight factor for 50% of the room. And there's also something about the minimum daylight factor for 95% of the room. There are no standards, or there are no requirements inside this standard, but there are some recommendations, and the recommendations say that you should go up to 300 lux for 50% of your room. And if you make this into a daylight factor, it would be 2.1%. And which is also, and something which is also very nice to read, is that everything is the same for each function. So there's no difference if it's going to be an office, it's going to be residential, or whatever. Everything is for human, it's for us, and it should be 2.1%. So really different from what's in the Dutch building degree right now. We were, as a committee, we did some research. We were also looking at what was going on in the current standard and what's going on in the new standard. I will show you some slides afterwards. And we're heading for putting in something into the new Dutch building degree, the BBL. First of all, maybe a little bit of explanation for those who don't know the new standard right now. This is something which you do. You model a room, you take into a grid on a height of 85 centimeters. You have to be 0.5 meters apart from your wall, and then you have a grid where you calculate all your points. And then you have this area, this is the 50% where you look at. Most of the time, if you have only one window, it will be sort of halfway in your room. That's where you measure or calculate your daylight factor. We also have some researchers, most of the time they're graduates, and we work together, for example, with TU Delft, but also with other, like Haagse Hogeschool. And we did some research back in 2017, then the new standard was just out, and we took our own office as an example, and we just calculated what would the effect be if we calculate this at our own office. This is the front of our office, where we have a sort of a double window on the street side, and on the other side of the building, we sort of have the same facade, but we don't have the double facade. So we calculated 2 rooms, and then we sort of did this, we sort of had these numbers, and we saw, if you compare it to the 2.1%, for example, that the room on the southeast side would meet the requirements, but the room on the northwest side, because of the double facade, they wouldn't meet the requirements. So we saw the 1.9 versus the 0.4%. So that was sort of the first thing we did with the European standard. Then we got a question from the ministry to compare both methods. So the 2057, but also the new standards. What we did, and I go back a little bit, what we made it for different functions. We made residential buildings which just met the current requirements. So we put in a window which was actually just good enough to meet the Dutch building degree right now. And then different sizes, we sort of played a little bit with sort of shoeboxes, as you can see. And we looked at what the different sizes were, but also different ways of putting in your windows, as I showed before, and then also for different functions. This is part of the results, or these are part of the results, as you can see, and these are for residential buildings, where we have a residential building with a depth of 3.6, but also with a depth of 7.2, the blue and the green one in this graph. And then we sort of did different things with the obstructions. So the first ones, the A ones, those are the alphas, so these are the ones where there's an obstruction on the other side of the building, or there's a side thing, something like that. The B are the betas, so those are the overhangs we have in the balconies. and AB is a combination of those. So you can see what's sort of happening, and if you would like to see what it is in terms of the daylight factor, then you can look at what's on the other axis. Then you can see if you want to draw a line through these, you would sort of have a really strange line going through. So really difficult to compare them. So that's a sort of, well, we can say the problem. That's a sort of, I talked about pears before. These are the apples and the pears, you could say, because they're really difficult to compare. And sometimes, if you look at an average, sometimes it will be worse, and sometimes it will be better than we're seeing right now. And we have to find sort of a new line if you want to go further with these future requirements. That was sort of the investigation we had. And then it was sort of out, but it's not in the new building degree yet. There was a table where there were suggested requirements for the daylight factor. But there was also, you could see, and you go a little bit back, that sometimes you do have problems. So there will be residential buildings which don't meet the requirements. They will meet it right now, but if you will do it like this, they won't meet the requirement in the future. And that's something we have to sort out. We're going to sort out it in the coming years. How we're going to do this, how we're going from this old standard or the current standard to the future standard. On the go, we did some further researches. There was a graduation project from a guy named Chico at our office, and he did some variations. And this is something this is my gift to you, you could say, because in the end, it is a lot of calculations. And if you want to play with this, you can scan this, or otherwise you get the presentation afterwards, I think, so you get it as well. And what we also did is that we looked a little bit at the Villa Bosch, at what was going on. And so we had got the floor plans, and we looked at what it would look like if you look at the daylight factor. And then you can see that there's a lot of light from this side coming in. And you can also see the sky window over there, which is having an effect in the middle of the room. And so it goes on. But in the end, this is only a way of looking at it with a clouded sky. There's going to be a blue sky as well. So what would be very interesting to look a little bit further and go to the more detailed method, which is also in the 17037, and look at a way of taking this into account. And then we have the time to look at a cloudy, not at a cloudy sky, but at a clear sky, and we have to make more detailed calculations. But then you can make a difference between, for example, the north and the south facade, because you take into account the sun as well. And if you look at this, this will be the effect of the orientation. If you would have a south facade, that's the lower one, you would get up to 76%, and the north side would be 45%. So it's much better on the south side. So you could actually make your windows smaller on this side. But there's one thing you have to take into account. This is when you don't use anything like sun shading. If you use sun shading, you should do it even a little bit better than this, because you have to also take into account when the sun is going, when you put down your screens, and then calculate it again. Then it would be different. So in the end, this is practical guideline. I'm going further through this. In the end, and this is something we did for some fee. I'm going really fast right now because I want to show this. In the end, I think we should look at a different way for daylight. So we look at daylight and look at the new way at this. And we can look at all different solutions, but we don't have to look only at daylight. We also have to look at all the other different elements. So we look at the amount of sun which is getting in. And we can look at the amount of cooling we need, and we can look at the amount of heating, and then you get a sort of an overall score where you have your climate-based design and you take into account everything, and you can make the perfect facade, together with the architects, of course. So that's sort of the thing I would like to show you. Yeah.